Let's see. There we go. Now it's working. Alrighty. Um, what's up? Everyone can hear me now. Had a mic error. It wasn't working, so I had to reboot. So got the camera on the camera stand because we've been moving around a lot. Um, if this phone rings, it's a loud, annoying sound. I'm on call, so I have to take a message on the information and give it to a coworker of mine who is on call. So I'm just going through making sure everything is straight. Um, on here. Let's go back to this. There we go. So, how's everyone doing this lovely Saturday? I'm having the camera here, this here, but I'm mostly gonna be focusing y'all on this while I face this, and so I can see everything I'm doing for you. So, everyone have a good weekend so far. Hello, Jennifer or Danny, whichever one you are. Yeah, I've got to do continuing education to keep my certifications alive as well. So, we're gonna start a little strange here. I've got give you an idea. We've got schematics here. We have controls here, and I have a book I'm about to pop up here. So we are going to start with. Oh, there we go. Not a problem. We're going to start with symbols, basically. That's right. Let's do it this way. That's why it's doing that. All right. So let's start out here. We have single pull, single throw. And we're going to go through all these symbols, talk about them, and give it to where y'all can take a picture of the page or screenshot it, however, here in a minute. You have different styles, single pole, single throw. So that's like your light switches. Okay. Single pole, double throw. Power comes in, it can either go one or two. Now, one thing you need to understand, all your switches are shown in their natural position with no power applied. So This is showing when power is de-energized, this is how that switch is. Same with all of these. So this double throw switch, this side is energized, this side is not. This side's energized, this side is not on these. So that's how all this is energized, set up. So double pole, double pole, triple throw switch. You'll see more of these in commercial. Um, double pole, double pole, single throw, double pole, double throw. You'll see all these. They have triple pole throws as well. All right, thermostat opens on a rise. So this icon here, that is for temperature. Okay, so here's your temperature. It drops on a close and opens on a rise. So when your thermostat is calling for heat, because it's gotten cold, this side has dropped. Thermostat closes on a rise for cooling. That means when you have it set for the cool mode, this side rises up, it clicks, it's gotten hot. Once it cools off, it drops down. Now, pressure switches. Your half circle icon is for it stands for pressure. Okay, so just like your temperature switches, your pressure switches do the same thing. So pressure switch opens on a rise. Well, what's going on, Ryan? Pressure switch open and rise. This would be like your high pressure switches. Okay, so notice how this is not when power is applied. Your high pressure switch is open. Pressure switch closes on a rise. It's your low pressure. That means it's not going to close until we have pressure. So if you grab a two pressure switches out the box and you're not sure which one it is, oh, Jennifer's got a tech support call. If you're not sure which pressure switch it is, your high pressure switch will always be closed out of the box because there's no pressure to open it. Your low pressure switch will be open because there's nothing to close it. Okay. Push buttons. You'll see these on your rollout limits or some high limits depending on the style you have. So normally closed push button, normally open push button. This is more or less right here. Normally closed is normally your rollout limits on those there. Humidistat. And that's your symbol for humidistat. And basically, if it doesn't have enough if the humidity gets too low or too high, it closes and opens. It's not really strange, different than what we've been dealing with so far. Time delay relay. It's your symbol for time delay. Now you can have an aftermarket time delay into a system. You can have a time delay built into the logic board, time delay built into the thermostat, but you can also add a time delay. Contacts. Here's your standard contact right here. Okay, that's your symbol for your contacts, for your relays. Let me move this down a little bit. All right, real simple. Compressor, evaporator fan motor, condenser fan motor, reversing valve solenoid. They're just straight circles with letters in them. Nothing different, nothing you haven't seen before. So let's go back over here. You have your hot gas solenoid up here on the top right. You're going to have those on certain style package units. Reheats, relay coil, your red light signal. If you're not sure what the red light signal is, that is the red light that comes on your thermostat, basically, or if you have an indicator light on your system. This is something people need to understand. Single phase and three phase compressors. Basically, they both look the same, but your single phase has the word compressor built in the circle and your lines off to one side. As where your three phase compressor is written off the outside the circle, and your flux capacitor design look is right in the center. Heaters, crankcase heaters, defrost heaters, and electric heat strip heaters. All symbols look the same, especially your defrost and your crankcase. And your heater one is a little less rigid than the other ones. All right, we have fuse, circuit breaker, inline thermal overload. So where would you have this at? Inside your compressor, basically. Magnetic overload, pilot duty overload, relay or contactor with no contacts, with one contact, triple pole, and transformer. So here's your contactor icons and our transformer. Uh, just reading through some of the schematics real quick. So those are most of your basic symbols. Okay, I'm gonna go on the board and show you some symbols that are not there, and we're gonna go over some of these here. So I'm gonna pick this up, try to get a good picture here. If Jennifer wants to do a screenshot of this, good. All right. So let me get y'all back on level here. Turn that off. Move this out the way. All right. So one of the icons is a triangle. That's a sail switch or flag, however you want to do it. Sometimes it looks like that. You know, people draw them differently. But this is your, we'll go with the one on the right. I think it's the correct one here. Basically, what a sail switch does is it checks for movement of air. So back in the day, we used to have electronic air cleaners that had to have a sail switch on there in order to show that, hey, I'm moving air, let's bring on the electronic air cleaner. Or you'd have sail switches for certain things, like, okay, you'd have a sail switch to prove that the air is moving before the heat strips would come on big commercial units. Yes, Mac, that's actually the book I taught out of at school. Um, so yes. Move this a little closer. There we go. So that's that there. So any switch shown standard de-energized. That way everyone understands, all are energized. So this can be pressure, temperature. It could be any of the switches. Just note that it's always shown and de-energized in all your schematics. Okay? Yes. Now, some of them will show like this. That's open on a rise. So you have open on rise. You have open on fall, right? So open on fall would be differences. See how your contact points are like this. That's really like this. So this would be open on a rise or close, open on a fall or close on a rise. Okay. They work hand in hand. So knowing all this, the basics, the simple is the first starts of everything. Our next step is to get into actual schematics. So what I have for us today is a schematic out of a carrier heat pump. I also have it on here, so I'm gonna do a share screen as well. We're gonna run through these schematics and everything. And just for fun, I brought the box of everything from that unit. So you can see your switches as well. And here's your reversing valve, solenoid. So let me bring this closer. Drop you down. All right. Turn it just a hair. There we go. Everyone should be able to see that. All right. So let's start here on the left side of the connection diagram. You have your C, Y, O, W, and R. Okay. Basic, plain, simple. Let's start there. This is the side that's always easier for most people to read, but it sometimes also a little confusing. Let's start with our Y circuit. Okay. Go over Y through our logic board out. The first thing we're going to hit is our low pressure switch. So everyone can see LPS. If you're not sure what it is, you can go to your legend and it says low pressure switch. Legends are great to give you what your definitions of the terminals are. Go through our low pressure switch so you can see how your switch is drawn. It opens on a fall of pressure. Okay. Then it immediately connects. So this is a connection point. That's what that dot means. It's a junction. It connects to our high pressure switch. As you can see here in the picture, it is drawn to where it opens on a rise in pressure. Then it turns and comes back into our T1 part of our logic board. Okay. So once we go over the schematic, I'll put the box up here and you can see everything. All right. Here's our CTD, which is our time delay relay, which is built into the logic board. And there's your diagram. There's your icon. Okay. Now let's follow our reversing valve, which is our O terminal. It comes up and comes over in two different branches. All right. I'm going to take the right branch and follow over here to O. All right. And you can see over here, it goes through the board as well. And it also hits our R terminal for our DFT, which is our defrost time sensor. So when we go through our orange wires, we go through to our RSV, which you can see the icon for reversing valve solenoid. And it just goes right back into our board. So reversing valve solenoid goes in, goes out, 24 volts. This side is your common, this side is your 24. And if we follow back down to here, we have our R and DFT, which DFT comes out and goes back into our logic board for defrost. But then we have our sensor wire, which goes through pink, hits our defrost timer, thermostat, excuse me. And here's our drawn. See how it's drawn open. Everything is de-energized. So since it closes on a drop in temperature, you can see it's drawn open there. And it basically says, okay, once I've gotten cold to my set point of what the sensor set that closes at, it will close. And it says after our timer and our defrost board, our dip switch settings here, 30, 60, or 90 for your defrost is what it will go through. Depending on your region, your dip switches are what you need to set it for. So these are this is just the first part of it. All your R does go in here is your R goes in and does powering of the logic board. Common goes in and is the common side of everything on the low voltage side. So now let me zoom up just a hair. We have everything above this area right here, above your high pressure, low pressure switch, is basically your high voltage section, okay, of your connection diagram. One thing I want everyone to put out at and notice. Let's go right here where your power supply comes in, L1, L2. If you see how it says 11, where it says contactor, it says 11 and 21, and then 23 and 23. This is a key point on your schematics that's telling you a lot of information right there without using it. I can't use I'm using sorry, didn't think about it. I'm using the mouse on the screen and not even thinking it's not on y'all. All right, right here. Okay. I'm using the mouse and not even thinking about it. Thanks, Mike. Yes, I need a tiny tie hand. And trust me, a laser would be too bright on this. So we'll go back through real quick. Here's our low pressure. Here's the high pressure. Defrost sensor, reversing valve solenoid. Up here, 11, 21, 23, 23. This area right here is telling you a lot of information about that contactor immediately. Because we have the 11 and 21, that's telling you have a connection point. That means there's a break, there's a relay, there's a contact there. Hence how it's drawn with the two lines right there. The 2323 tells me there is no contact. It's straight through. If that was a two-pole contactor, it'd be 13 and 23, not 23 and 23. So that's definitely information there. Let me try to zoom in a little bit more here. Make it a little bit bigger for you. There you go. So you can see right here, 11, 21, 23, 23. All right. Now you have a lot going on this side of the contactor. Line side, load side. Okay. 11, 23, 21, 23. So your 21s are your load. Your lower numbers are your line. If you have right here, we follow on your L1 on 11, come up going through. First thing we come to is a crankcase heater to a crankcase heater temperature switch, and then back down to 21. So what's happening is that switch is sensing the temperature of the discharge line, and it says, "Hey, I'm up and running. You can stop the crankcase heater," and it opens that crankcase heater. It opens on a rise. All right. So let's continue with the 21. We've got 1, 2, 3 lines that come off of 21. Okay. The first line, contact. All right. So we're not worried about the crankcase heater side. We're going to work right here. You're going to follow our black line up. Start relay. So this so we have a start relay ability to have it in here. Now, a lot of the start relay stuff is optional. It's not required. Sometimes you don't have it. So you go through our start relay to our capacitor. All right. So there's our symbol for our capacitor. We're going to come back over here to 21. And it goes from 21 to our common on our compressor. C is your common. And you can see the temperature icon right there, relay switch. So you see that right there. It's in the common, in the winding. So when that winding gets hot, it opens up. That is why a lot of us, when we're testing our compressors out, our common winding always opens up when it overheats, because it has this built-in temperature probe into the winding, into your setup, into your compressor. It's right there. That's why everyone's like, why is it always my common side? Well, that's why. Give me a second. Hello. Okay. Mm-hmm. All right. Thank you very much. Bye. Sorry about that, guys. I gotta send a text real quick to my coworker who's covering me for doing this. All right. So get back to our compressor here. So coming off of 21 common, off of our start relay, comes up over here to our capacitor. And that's going to our Herm side of the capacitor, because the other side of that comes off and goes to the start of your compressor. The last terminal we have is our run. That comes off of 23. That's our 240. That's where we're making our connection. Okay. Yeah, the other wire coming off of 23 comes over into our capacitor. So this is where we're going from. This side is 120, and that side is the common side is 120. So this is where 240 gets thrown through at it. Now, one thing people need to realize is your capacitor is oval shaped or round, depending on your style. C used to stand for center, but it actually, we just call it common. Okay. You have your C, your Herm, and your fan. So last thing on our capacitor is our fan. So that comes off here, our brown wire, to our outdoor fan motor. Now, yellow wire comes off your fan motor, goes to common on your capacitor, and then you need to have high voltage. So remember the fourth wire on 21, it comes down, it goes over, backed out to OF1, outdoor fan number one, outdoor fan two. This is for when it goes to defrost, it kills the fan. And that comes back up into our fan motor. Now, what some people don't realize, and you can do, and they're like, you can't do that. That's not right. This wire right here, coming off of your fan motor, going to common of the capacitor, can also come off of here and go straight to the 23 terminal. Okay. They're using the capacitor as a junction point for that terminal. That's all they're doing. This can go over there. So if you don't want to put it there or it's tight and you can reach back over here, go ahead. But that's how the schematic is drawn. Okay. Now, if I slide over a little bit here, get y'all in focus. I don't know why doesn't want to focus. Let me try the little extra light on this. All right. There we go. Focused. Ladder diagram. They're a little more simpler to read for some people. Some people are a little more confusing because there's less information and there's less drawing in the ladder diagram. Same amount of information. Okay. It's split up a little differently where our line was 1 and 2. Now our line is 1 and 2. Okay. Goes to the same thing we just went through over here on that. And same down here. Here's your low voltage connections right here. Shows common over here. Common down here. So everything for that we went through on this side is right here. Some people don't like your ladder diagrams. It's not always the easiest to read. So now that we have that, I'll leave that there if anyone wants to get a screenshot of that. Real quick. Got it, Jen? All right. So let's bring you back up, bring you back around. And here's our control box. So what you saw in the picture, your schematics, now you can see in person. So here's our low voltage. Now here's where our low voltage connects right here. So I'm gonna pull this pin out, and as everyone can see, you have ORWY, then space and C. So ORWY and a space for C. Um, if you ever come across one of these where your common wire, your black wire, is directly next to yellow, I mean, so the wire is not sitting here, it's right next to it. There's not a gap there. You need to get that pin puller, pull it out and move it over a spot. The only reason I say that is I had one that came from the factory like that, and it threw us for a loop before we actually realized it, because these are small things that technicians overlook when diagnosing. If you notice, there's spots in the back here, so you can put your meter there and take take your voltage readings, or you can do it at the wire nuts. Wire nuts are a lot easier, but you always pull this off and just to see if you're getting a call as well. So I'm gonna leave this out the way now, so we can continue seeing. So just a little closer. So up here we have T2, common, common, O. All right. So our O and our common for reversing valve are together. Down here, our defrost thermostat, excuse me, defrost thermostat. Our dip switches for our defrost setting. See that this is your connection point between your high and low pressure switch. Low pressure, high pressure, right here. Here's the other ends. If I were to cut this off and take a continuity between this wire, and these two blues and these two yellows, either it would go or not, because we don't have any pressure. Here's your outdoor fan. So right here, this wire, OF1, OF2, 11, 23, 23, 21. Single pole contactor. Off to our capacitor. High pressure switch. Low pressure switch. Now, there have been numerous videos that you would see leaks here, the tops of these, or actually at the wire. I haven't run across one, but I've seen the videos. Defrost thermostat. These are not the easiest to get to, as you can see. You have to wrap it around a piece of 3/8 copper, and you can get it in there. You have to click it in, and sometimes you're trying to push on it, it goes back. You can barely get your hand back there to work on these things. I went over that while you were in on the phone. So difference between these two, out of the box, your low pressure will be open, your high pressure will be closed, because there's no pressure on the switch to force the switch to open up. Okay. Um, Always go off the schematic to tell you which one is which, where they connect. Um, Usually 9 times out of 10, your high pressure's on your discharge, your low pressure's on your suction. 9 times out of 10. And here's a very worn reversing valve magnetic coil. You can see the bare wire there. That happened in transport. And carrier likes to put this beautiful black ring to where it goes to the bottom of the casing here to prevent any kind of wire rubbing or whatsoever. Some other manufacturers take it through the cabinet and don't put any protection on there, and you'll get wire rubs on the metal and everything else. Also, these wires, when they sit up against copper pipes, they can rub and everything else. And then here's your compressor plug that goes on your pecker head. And you can see right here on the plug, it says L1 is common, L2S, which is start, and L3 is run. If you ever get a one that this has been blown off the compressor and you pull it and look and there's a little metal probe sticking inside of there, you have a problem. If you ever open it up and you see all that is dry rotted and cracked, it very well may be getting cross voltage between one of the other terminals because of that as well. All right. Manufacturers don't like strapping down, don't strap these down properly enough in the units. So we have shorts all the time. We've had the high voltage wires that rub and blow holes in the copper. But here's this. So this is basically just the carrier heat pump section. I'm going to flip the camera around and we're going to do some screen sharing because I have some stuff on the computer for you. So let me get my beautiful face back up in here. All right. Nope. And if I can. There it is, share screen. Um, Let me pull up the documents first because it wants to know where I want to share. Downloads. I'm not sure if this is going to work, so give me a second here. So that's not what I wanted. I might not be able to share the screen. I might have to put the camera onto it, guys. It's not doing what I wanted to do. Windows. Oh, wait, there we go. Got it. All right, so here we go. Took me a minute. This is off of a Lennox gas furnace. Okay. And I need to just make it bigger. Give me a second here. There we go. All right, so everyone should see this on their page, on their screen. So I can zoom in on it for you. All right, it's good. Just making sure it's up there. I can't see if I open this back up full screen. All right, so we're going to come over here to the left side, the top half of this schematic, and you're going to have your low voltage connections there. Okay. We're just going to kind of touch base on this because some of the icons you saw in the heat pump, you'll see over here. So here's our low voltage schematic. Here's our schematic here. Let's start at the top here. You have primary gas limit. You have your temperature switch there, and a flame rollout switch. You have a temperature switch there as well. Um, if you go to your right here, another flame rollout switch, temperature sensor. Then you have a high heat pressure switch and a low heat pressure switch. As you can see, we have, again, pressure switches. It might not be the same pressure switch you use in refrigeration, but it's still the same icon drawn. All right. So just because it's a temperature or pressure switch doesn't mean it's designated for heat pumps or ACs or gas. They're all the same. Just a matter of what they're doing. All right. Then you go down here to S21 below the high and low. You have a secondary limit, another temperature switch. Go over here to the right in the middle of the screen. Room thermostat. 1, 2, 3. Temperature switches. Fan auto on. Single pole, double throw. Auto or on. So you can see some of the stuff we discussed is right here in our thermostat alone as well. Let's move over into our center here. We have pressure switch, 1, 2, 3, 4, 5 temperature switches. So when you're checking out a system, you've got a rollout limit or whatever, you've got to go through all these temperature switches. Counting up how many are in the schematic helps you understand how many you need to check. Okay. Low heat pressure switch, high heat pressure switch. Just going through. And then if you come over here to where your transformer is, coming off your blue line, you see a little circuit breaker design. So they had a resettable fuse as a circuit breaker versus a fuse. If you come over to the left, you can just see everything for the high voltage side. Now, all these arrows are plugs. All right. So it'll tell you what plug terminal it is. Oops. Let me go back. Now, notice there is no real legend on this system, on this. This is everything it gives you on the schematic. No legend. You have to start to figure some things out for yourself on these higher class schematics. Give me a second. My coworker has not replied back to me. Did you get the text? Work phone. Oh, Mike Fisher. Gas smell. Yeah. Well, it's a rental property. I'll send it. I'll send it to your personal. All right. No, that explains why. All right. Sorry about that. So let's go to our next schematic. Nope, wrong way. So we have, again, basics out of the book: single pole, single throw, single pole, double throw, double pole, single throw, double pole, double throw. Push buttons, rotary switches, relay contacts. Oh, I'm gonna put it back here. Jen, give me a sec. Yeah, I did. Yeah, give him a shout. Yes, I'm in. I'm in the middle of class. Remember, you were gonna cover me. All right. Bye. Sorry, guys. I really am. Jen, shoot me a text once you get. I'm gonna give you like 5, 10 seconds to get a picture of that for class if you want. All right. So everyone might want to take a picture of this. This is good information. It shows you your level switch, pressure switch, limit switch, float switches, temperature switches, delay pickup switches. So everything there, your contacts, three-phase drought breakers, but your main side is normally open, normally closed. That's what I want you to see. You can see how they're drawn one way or the other. All right. And our flow switch, as we were talking about earlier. Temperature switch normally open, normally closed. Flow switches, different drawings, same situation. Time delays. As you can see how the icons are written. Now, the biggest thing is relay time delay on normally open. And that's delay on. So the arrow faces up. Delay offs are arrows facing down. Don't get those confused. They're like that for a reason. And if you're working on commercial stuff, you'll have a horn, a buzzer, or a bell for enunciators on smoke detectors. Just a couple of extra fuse pictures. Shows what your fuse look like. Heat overload. Normally closed contact, normally open contact. And then another, basically, carrier diagram. This one's a little different. I believe this one's carrier. No, it's not carrier. Different information. But if you look, you notice this schematic is almost identical to the schematic of the carrier heat pump. It has a lot of the same symbols, same how everything's wired up. So a lot of your heat pumps are generally wired up the same, as you can see. Different manufacturers, same situation here. You've got low pressure switch coming off of T1, T2. See here, defrost thermostat. If you notice, this does not have a high pressure switch. This one only has a low pressure switch. If you go on the left hand side of the schematic, you'll see just low pressure, no high pressure whatsoever. So not every unit has a high pressure switch. Outdoor thermostat, defrost, which controls the W2. So this could be help for the ODT. It could be used for help staging in your heat strips. And when it gets cold, and it says, okay, well, I won't let the heat strips come into cold unless it's a certain temperature. So not every schematic is the same, and not every system's the same, but they all look generally the same. And here's the other carrier one I was looking at. DTS, discharge temperature switch. Right there in the big middle of your schematic. If you notice, this one has a discharge temperature switch, and the one I have did not. Also, you can see how the schematic is drawn a little differently with this one here. It just has a connection diagram on this picture, where the other one had the ladder right next to the connection. Very similar, drawn a little differently. Notice on the only has one logic versus two on there, because you have the other logic section right here in the middle. So again, same manufacturer, different diagram for the system, but still pretty much the same thing. The the asterisk right here may be factory or field installed. Okay, so some have them, some don't. And that is the end of that part there. All right, got it. Good, Jen. I couldn't see it because when I had that screen up, I couldn't read anything. Let me go through. So, all right. Now, I didn't mark the page. Ohm's law. Okay. Basic, simple. Everyone uses it. You know what's great? Our meters do it for us. The last time I used that formula was when I was doing class, when I got taught this. I know, that was years ago. Actually, 25 years ago to be exact. So, let me move the box out the way here. I'm going to flip y'all back around. It's a beautiful shade of wall we have. All right. So as you can see in the heaters, bring the light back up here so I can stop shadow casting. It's so hard doing this without having my lab. So L1, your electron flow is going through your heater, back through your other side of your elements, back to ground. You know, this says 120, but figure this is 240. Okay, this is where your heat strips come into play. And yes, this does say 208 volts. And yes, you can have high voltage pressure switches and thermostats. Just because it's on a system doesn't mean your control voltage is always 24 volts. Very funny, Jen. Again, here, high voltage lines, high voltage controls. Compressor. Now, the next thing we want to talk about, parallel circuits. Okay. There are some things that people don't understand. Here's your line, heater, neutral. Parallel means from point A to point B. So going from line to neutral. Okay. Each one has its own power tap and each one has its own neutral. There's difference between parallel and series, and people get this confusing all the time. Okay. Your condenser fan motor and your compressor are always in parallel with each other because when power is applied, they both come on. Okay. Your pressure switches on the schematics that we saw, the low and high pressure, those are in series because they start at one point, go from one switch to the next switch, and back to the end. So I'm going to go over here, back to this page real quick here. This is a series circuit. Power comes in, goes through our high pressure, through our low pressure, through our thermostat, back to our motor. That's the difference. Series means they all line up. If one fails, it kills everything. So if I lost my low pressure switch, I'd have power through my high pressure into my low pressure and nothing out of my thermostat. If I had power in my high pressure and it opened up, I wouldn't have any voltage going this direction. So just this is where it's got to go in series. Everything goes straight through. One switch breaks, they can all break. All right. So that. And we're going to draw it out real quick so everyone can get a full view of, yes. All right. Let's do a typical series situation. You have your easy trap, an SS2, and a pan switch. Okay. Let me kill this. So our easy trap, we have 2 wires. SS2, we have 2 wires. And our pan switch, we have 2 wires. Now, everyone breaks differently. Some people will break that. Some people will break that. The old saying was you break R so that way the fan runs but no compressor. Okay. Some people will even go as the breaking common. That way, in case a wire gets messed up, you don't have to run the risk of running into a short. I can get that. I can understand that. But we're just for simplicity, we're gonna break R. So 24 air handler comes into our easy trap. All right. Comes out of our easy trap over to our SS2, out of our SS2 to our pan switch, out of our pan switch, basically, are and there you go. Now, if you have a straight AC, it'd only be R the thermostat. Okay. But yes, that is a series circuit. Everything comes in and out, in and out, in and out, back to that situation. This. You're welcome, Jen. Not a problem. Go get her. So that is our typical series circuit we use every day when we're doing installs or working on things. Okay, when we're installing these switches or if we're trying to diagnose a bad switch or whatever. And basically, like I said, there you go. And if you really want to get technical, you can also your blow and your heat strips are in the same parallel circuit. Okay, so your blower and your heat strips all have come off of line 1. They get energized to the relays and go straight to line 2. This gets energized off your contactor from line 1 to line 2. So, do y'all have any questions, concerns, anything you want to discuss, ask questions on? I got my book here. I got my toys. Ask away. Then roll through the comments while people are thinking. And there's only 5 of y'all in here. Do want to thank everyone for showing up. Snapshot and put on PowerPoint. Yeah. And I'm all caught up. Let's see here. Not a problem. Thanks, everyone. Let's see here. Yeah, it's called a new motor. Thank you, everything. I appreciate it. Mike, thank you. What's going on, Kanan? So, Kanan, go back and watch this one. The other one I did as well. So, if no one has any questions, I'm gonna get off of here and see if anybody will catch that call. But I think my coworker got it, which is great because he forgot he was covering for me. He says he's getting old in his old age. He's forgetting things. He's not much older than me. So I appreciate everyone coming in. Um, I hope it helped out. I hope it's helped people out. I hope it helps y'all out, and then using it for training out your coworkers, or if you know someone who's having issues with it, send it their way. If I can help 5 people out with it, that's all that matters, is helping out and getting them the best understanding of it possible. Um, so next week we are doing thermostats. So I don't foresee thermostats taking an hour and a half. We're going to discuss thermostats. We're going to go over thermostats. I'm going to try and have some thermostats here. I'm working on building a board for basic circuits so I can have it up here so y'all can see it and how it operates. And then with trusting and troubleshooting, going from there. So now just keep in mind the class on the 8th has been moved to the 15th. Mike, HVAC Mike, is doing a class that day on the 8th. I will not be available that day, so he's doing a class that day. So I'm doing the 15th and the 22nd back-to-back weekends. So I'll see y'all in a few weeks on the 15th. Yes, Mike's class will be on Facebook Live and reposted on the YouTube. Thanks, everyone. Have a good one and enjoy the rest of your weekend.